Hello everyone, today in this video we'll be discussing the module 3 of DBMS BCS403, and in this module we have about the normalization. Okay, what is normalization? We are making the existing database better. Okay, whatever is the existing database is there, they can have errors. Okay, errors means when you perform some operations on it, like the updating or inserting some values or deleting some values. At that time it will be causing some issues in that. Okay, we'll be seeing what those issues is, and sometimes two or more tables are connected with each other. If you delete something from here, it should be deleted from here also. If you don't do that, something will be here which is not existing. Okay, and that will cause issues. So we'll be discussing all of this, what all you need to know from the exam point of view. So make sure you watch this video till the end, and before starting, please do like and subscribe. It helps me make more videos like this, and if you have any doubt, you can ping me on Instagram. Now, getting with start with the first topic, it is about the informal design guidelines for relation schema. Okay, so whenever you want to create a table and insert the values inside it and maintain a database, okay, so in that time you need to follow some guidelines. Okay, so there are mainly four informal guidelines, and this is very important question from exam point of view. So what are those guidelines? The semantics should be clear in the schemas. Semantics means whatever you are defining, it should be having a meaning. Meaningless things should not be defined. Okay, reducing redundant information in tables. What is redundant? Redundant means if you have defined apple previously and again you are defining apple, again you are defining matter, are you mad or what? If you are defining the same thing again and again, that should be avoided. Okay, reducing redundant information in the tables. Reducing the null values in tuples means if any row is there, it has so many null values, and it has another values, another row is there which also has the null values. So you have to reduce that kind of rows which have null values, and row is nothing but tuples. Okay, in database terminology, we'll be calling the rows as tuples. Fourth is disallowing the possibility of generating spurious tuples. Spurious tuples means the tuples which do not exist. How do these tuples get generated? Wait for it. We'll be coming to this one. Okay, first let's discuss semantics should be clear in the schema. How does the semantics, whatever we define, it has a proper meaning. Okay, so basically first you have to plan. Okay, what you are going to design it for. For example, if you are going to design a database for the company, there will be having the employees, you will be having the projects, you'll be having dependents, and you'll be having working on, and you'll be having your department location, all those things, right? So it will be a meaningful database which will be having some connections, not some random tables like table x, table y, table z. We are not able to understand anything. So if you make such a kind of database, again you have to define in a separate documentation what does x table do, what does y table do. Instead of that, just simply make a meaningful name and keep a connection between them. Okay, it should be reflecting some real world scenario. That's the first guideline. Okay, all the relations present in the table should have proper meaning associated with them. Okay, and semantics of a relation means resulting from the interpretation of the attribute value in a tuple. Whatever the attribute value we see, for example, SSN. SSN means what? Like roll number. Okay, employee's roll number, we call it as SSN. So it has a meaning. What is B date? B date means birth date. Address means where the person lives. So every attribute here has a meaning. Okay, so that is what is called semantics. A simplified version of the company relational database schema considered as this. So company is a database. Okay, and inside the database we have many different tables. So these are the different tables present here. Okay, and each table you can see there is meaningful names present, and then names, once you read, you will be able to understand what it is. Let's take example DMGR. What does this mean? D means department, MGR means manager, SSN means the roll number. The roll number or the SSN of the manager of that particular department is stored here. Okay, and PK means primary key, which is by using which we will be able to identify the whole row, and it should be unique. Two tuples cannot be having same SSN. Means can you imagine having two persons in the same classroom with the same roll number? It doesn't exist, right? Every person will be having a unique roll number. Like that only SSN should also be unique. Next is the FK means foreign key. Foreign key means whatever is given here. D number means this employee is working in which department, but department number is not a key of this table. It is a key of this table, right? So whatever is given here, that we are taking and putting here in order to connect the employee with that particular database department number. Okay, so that is what is the tables are present here, and the meaning should be there. Okay, and this is an example also given, and like that you can have the department table and the values are given here. Project is also given here. You have a very clear and beautiful things here, which is project name, p number, p location. Everything is easy to understand. Okay, that's the main key point you need to know. Whenever you define a table, it should be easy to understand. So this is the first guideline. Design a relational schema so that it is easy to explain its meaning. Do not combine attributes for multiple entity types and relationship types into a single relation. Don't put all 100 things in one place. Make it different attributes. Okay, Intuitively, if a relation schema corresponds to one entity type or one relationship type, it is straightforward to explain its meaning. Otherwise, it's corresponding to a mixture of multiple entities, then it will be hard or ambiguous to explain what its meaning is, right? Sometimes you will only forget you have defined 1,000 things in this attribute, so you'll be not able to explain what those 1,000 things are. So that is the first guideline: make it proper and make it easier to understand. The second informal guideline is the redundant information in tuples and update anomalies. So redundant information means repeated information. It should be reduced. Redundancy should be reduced to increase the space efficiency. If you have saved one thing 100 times, what is the point? The space is captured here, and you are just storing one thing 100 times. So instead of that, store it just one time. That is more efficient, right? So reduce the redundancy. Now, during the insertion of data and the updation of data, there can happen some anomalies. Anomalies means issues. So while inserting some data, for example, if you have a school database and you're inserting a student's record here, like the student's name and stuff, okay, so that is called as insertion. What an anomaly is in this case: insertion anomaly means insertion of data may cause issue. For example, if someone tries to create new department, okay, I created a new department here, that is dept new, okay. Initially there would be no employees. Obviously I created a new department, till now no employees are there, and employee has to be filled with nulls, because whenever I create a department, I have to fill in the database what is the value for the employees. So since there are no employees, I'll be filling it as null. Now, filling the employee as null, what does that mean? This causes integrity constraint, because the employee SSN is a primary key and it cannot be null. When you are filling the employee as null, so employee consists of all the keys. Inside all the keys there is SSN as well, so SSN also becomes null, so that has to be avoided, okay. So that is called as a integrity insertion anomaly. Like that only we have the next one, which is the deletion anomaly. If we delete the last employee from any department, okay, there is a department and one last employee is present. If you delete this employee, then the database for that department will become null. Means all the employees which are present, that will become null, because there is no employee. Again the same thing will happen, the department information will also go, because there is no employee, as well as the department will be having the null values in employee. So that means SSN is null. That will again cause some issues. So we cannot delete any department with last employee. At least one employee should be present. Modification anomaly: suppose we modified a manager's department from 4 to 5. Suppose a manager was working on product X. Now the manager is interested or shifted to product Y. Now I change this from X to Y, but the employee database, in the employee table, the manager's name will be there and their department will be there. So that manager's department is still pointing to X, but that manager is not working for X anymore. So we have to make change in the employee as well, employees table. So all those things has to be handled, otherwise the issues will happen and anomalies will happen, okay. Next, design the base relation schema so that no insertion, deletion or modification anomalies are present. We have to define all the things in the relation and the tables, such that like the things which I discussed now in the insertion, deletion and modification anomalies, that should not happen, okay. That is the second guideline. Third one is null values in tuples, okay. Null values can come due to various reasons, okay. It can be due to few or more attributes missing, okay. Attributes means what? In the employee table, what are the attributes? SSN is the attribute, employee name is the attribute, employee birth date is the attribute, employees general sex is the attribute, and employees birthday, not birthday, address is the attribute, and those kind of things, okay. So all those are called as attributes. Now in those attributes, some of the values can be null. Why it can be null? If it is null, what will happen? It will give wrong values for the sum or join operations. When we do the sum operation, how many rows are there? Because of null values, that entire row will not get considered. So but still some of the attributes will have value. It will not be fully filled, but some value will be there. It is still a row, but if you're taking the sum of something, it will not be considered here, so there will be causing an anomaly. Join means we are joining two tables. Because of empty values, we will be ignoring those values, so there will be again issues. Now for example, the attribute does not apply to this tuple. For example, the visa status might not be applicable to US students, because for the students the visa status will not be applicable, okay. They will be in study visa, right? So this visa status will be null at that place, okay. You cannot fill it with any values like invalid visa or valid visa, because visa is only not there. Next, the attribute value for the tuple is unknown. Like for example, date of birth might be unknown for an employee. The employee might not share the date of birth due to whatever reason, okay. So that will be unknown and it will be filled with null values. The value is known but absent. Absent means it has not been recorded yet. Like for example, home phone number, the person has a home phone number, but it is not available yet, so again there will be a null. So As far as possible, avoid placing attributes in a base relation whose values may frequently be null. If null values are unavoidable, make sure there is exceptional case and do not make it a major issue. Okay. The fourth one is the generation of spurious tuples. Okay, so what is spurious tuples? Spurious means false. Spurious tuples are generated when empty values from various tuples join, creating a tuple of impossible combination values. Okay, so design relation schema so that they can be joined with equality conditions on attributes that are appropriately related. Primary key, foreign key. Pairs in a way that guarantees no spurious or false tuple and existing tuples are generated. Avoid relation that contains matching attributes that are not foreign key, primary key combinations because joining on such attributes may produce spurious tuples. For example, if I take two tables, okay, in two tables, some values are null here and some values are filled. Another table is also there, some values are null and some values are filled. If you join these two values, it is not at all applicable. So suppose that this is a table for the student and this is a table for the office. Okay, now if you join these two, what will happen if all the values are filled? In that case, obviously it will not make sense to join these two, but due to empty values, some values from here gets joined with these values from here, and what happens, a new a spurious tuple will be created where a student is studying also and working also. Okay, so that kind of things don't exist in the current database where a student is studying and the working person is just working. Okay, we do not have a student who is both studying and working. Okay, so that will generate a tuple in which we will be getting a student who is studying and working, but that does not exist in the reality. Okay, so that kind of things we need to avoid. That's the fourth guideline. Okay, moving on to the next topic, which is functional dependencies. Okay, what is dependency? Dependency means depending. Okay, means if you want to x is dependent upon y, means y should be there, then only x will be there. If y is not there, x cannot function, like that. Okay, it is a constraint between two sets of attributes from the database. Okay, a functional dependency denoted by x is dependent upon y between the two sets of attributes x and y that are the subsets of R specifies a constraint on a possible tuple that can form a relation state of R. Okay, basically what does this mean is, if we take an example, SSN is dependent upon E name. If the employee name is there, then only SSN can be assigned. And if person name and person's location is there, then only person's number can be assigned. Now, if SSN and P number both are there, if R's are there, then only these two will be considered together. Means a person, unless and until the person spends hours working, there is no point of recording the SSN and P number because the person has not worked on that particular project. P number means project number. Okay, so the person has not worked on that. So like that kind of dependencies are there. Okay, so the following functional dependency, this is called as a functional dependency. Okay, where some attributes depends on some other attribute. Okay, now based on the functional dependency, we have different kinds of normal forms. Okay, what is normalization? It can be considered as a process of analyzing the given relation based on their functional descriptions and primary keys to achieve the desirable properties. Okay, so two main goals of normalization: minimize the data redundancy and minimize the insertion, deletion, and update anomalies. Means making the data more better. Okay, making the data more better. That is what is called the normalization. Next, the normal form of a relation refers to the highest normal form condition that it meets and hence indicates the degree to which it has been normalized. Okay, the normal form means the highest normal form, means how much better we could make at the max level, how much we can make it better. That is called as a normal form. Okay, which cannot be made more better. Okay, that is the last level, like that. So we have totally 5 levels. Okay, we'll be discussing each one by one. The first one is first normal form. So basically, whenever you get a database or a table, first thing you need to check if it is in first normal form or not. So basically what we check, it was defined to disallow multi-valued attributes. If multiple values are there in one attribute, we have to avoid it. Composite attributes means one attribute can have multiple values. Like you will have name. Okay, name can have first name, F name, middle name, and last name, right? So that is called a composite attribute. And the combinations, so those kind of things should not be there, it should be separate. Okay, separate means if a name column is there, it can have F name, M name, L name, like that. It should not be there. It should have separate columns for F name, M name, and L name. Okay, like that there should be separate columns instead of having a one column name and inside that filling everything. No, that should not happen. So it states that domain of an attribute must include only atomic. Atomic means simple and indivisible. You cannot divide f name further, right? F name is one single entity, but name can be divided further. F name, M name, and L name. So this should be avoided, and this is to be taken into consideration. And the values of any attribute in the tuple must be a single value from the domain of that attribute. You cannot have like for example car is an attribute, okay, and inside the car you fill all your favorite cars. It is just one car, you need to fill one value, okay. Choose your favorite car and fill this value here. You cannot put comma and write multiple values, okay. That is a wrong thing. Example, in this department table you have D locations, means Bel Air, Sugarland, and Houston, okay. So these three values are there, it should be separated, okay. It should not be in a single place. So basically what we do, research 5 and 3 this manager SSN is there and locations are 3. So we'll separate this into 3 different rows with the same manager SSN, with the same D number, and with the same department name. In the above example, D location, which is having 3 values, was broken into 3 tuples to satisfy the 1NF, okay. That is the first normal form. After that is done, you have ensured that every of the values have only single value. Then you'll be moving on to the second normal form. It is based on a concept of full functional dependency, okay. A functional dependency X depends on Y is a full functional dependency if any removal of attribute A from X, okay. Means the X will be having attributes. If we remove some attribute from X, at that case the dependency does not hold anymore, okay. That is for any attribute X. If we subtract A from it, it does not still depend on Y, okay. That is not functionally determined Y. That is the thing which is called as full functional dependency. Now a partial dependency means even if we remove some attributes from X, still it will hold that X minus A is still is dependent upon Y, like that, okay. So that is a functional dependency. Any attribute you remove, it becomes unfunctional. That is called as functional dependency, fully functional dependency. So in this example we can see that SSN is dependent on the P number and hours, okay, and SSN is also dependent upon the E name, and SSN and E name both are dependent upon the P name and P location. This can be divided into 3 parts. First is SSN P number and hours. We'll take it separate. FD1, FD2 will take it as separate. SSN in E name is there. FD3 will take it as separate. P number is there, okay. This is the P number, okay. P number with P name and P location. Now this is a fully dependent. Why? Because every attribute is dependent upon every attribute, and if you remove some attribute, it will cause issues, okay. None of the attributes are independent, okay. Everyone is dependent here, okay. That is called as second normal form. Third normal form, after you have done these two things, third is very easy. In 3NF it depends on transitive dependency, means if A is dependent upon B and B is dependent upon C, indirectly A is dependent upon C. I'll repeat, if A is dependent upon B and B is dependent upon C, indirectly A is dependent upon C. That is called as transitive dependency, okay. So in this case the SSN and D number, okay. So D number we are getting by using SSN, and D manager SSN we are getting using D number. So there is a transitive dependency. We can separate it here and we can separate it here, so that here the SSN and D number is there, and from the D number the further expansion is given separately, okay. Now stricter form of 3NF is called as Boy's code normal form, okay, BCNF. So here what is the thing is, whenever a non-trivial functional dependency X on Y holds, then X is a super key of R. Whenever a dependency is there, X should be a super key. What does this mean? Now in this example you can see the super key is nothing but the primary key, which is property ID, and in property ID we have a functional dependency which is country name, lot, and area, and another functional dependency is there. From lot and country name we have the functional dependency for the property ID and ID and area. Now again from area we have a functional dependency. This should not happen. Why? Because area is not a super key, but again something is getting dependent upon it. Something getting dependent upon non-primary key, that is a issue, okay. So because of this C goes to B, FD, FD2. Because of FD2 it is not in BCNF, okay. It is in 3NF but it is not in BCNF. How is it in 3NF? These two are going to C and C is going to this, okay. That is A goes to B, B goes to C, like that. But it is not BCNF because C should also be having a primary key for it to come from here, okay. Primary key means C should be underlined, okay. Now that is about the 3NF. Now we have the 4NF, which is multi-value dependency and fourth normal form. An employee may work on several projects, right? An employee will be there who will be working on 3 or 4 projects. So they may have several dependents. Dependents means their family members, okay. The employee will be having the family members, and that is called as dependents. So here many dependents are there for one employee, and one employee is working on many projects. So there is multiple dependencies. Whenever there is multiple dependency and we have to represent it, we will be using the fourth normal form. For example, Smith is working on project which is X, and Smith is working on project Y. So Smith is working on two projects, and X is the project, and the dependent name is John, and Y is the project and dependent name is Anna. Okay, so Smith X John and Smith X Anna, Smith Y Anna and Smith Y John. So if we divide it into two parts, okay, because this is not in fourth normal form, it has multiple values, multiple value dependency is there. One person is working for different projects and different people are dependent upon one person. Now if we separate it, Smith is working on X and Smith is working on Y, as well as Smith is having a dependent John and Anna. So it is into two multiple value dependencies, E name to P name and E name to D. Okay, and so we can also write it as X is dependent upon Y and Z, like that. Okay, like we can directly write it Smith is related to the P name and D name as well. Okay, but while writing the table you have to separate it and write. Okay, now that was about the 4NF and a relation schema. So what we discuss is not 4NF, it is the multi-value dependency. Okay, now 4NF we do some extra steps as well. It is same only, but we do some extra steps. So what is a 4NF? It is a set of dependencies in F. For each non-trivial multi-value dependency, X goes to Y. In F plus, X is a super key for R. So X is a super key, that also we discussed in the previous 3NF, right? X should be a super key, sorry, in BCNF. Now a table is in fourth normal form if it is in voice code normal form. So see, the normalization, it happens step by step. 1NF, then 2NF, then 3NF, then BCNF, then 4NF. If the previous one is not fulfilled, you cannot go with the next one. So the rule is, it is already in BCNF. Next is, it has no multi-value dependency, means whatever multi-valued are there, we separated the tables. Okay, for a single key there should be no two or more independent multiple valued facts. Okay, now see an example of table not in 4NF. Okay, this is an example for not in 4NF. Okay, don't get confused. This one is not in 4NF. Why is it not in 4NF? Okay, so see here, there is a student ID 101. Okay, so it's a single student who knows the languages English and French and who has the hobby painting and cricket. Okay, now we know that a student can know multiple languages and can have multiple hobbies, but languages and hobbies are independent of each other. The languages and hobbies, there is no dependency upon that. Okay, these are independent values. Only dependency is the student, right? So we'll have a multi-value dependency such as student is related to the language and student is related to hobby, but hobby and language is means it is not related. Now to convert it into 4NF so that it becomes related, what we do is separate into two tables: student ID with the language as well as student ID with the hobby. Now both are dependent. Student ID is dependent upon the language and student ID is dependent upon the hobby. In the previous section, what we had three things. So this was dependent, this was also dependent, but since three things are there, this will also be checked. This is not dependent. So whenever independent is there, we have to break it and make it dependent. Okay. Now after doing that, we are moving to the fifth normal form. So a table in 5NF is also called project join normal form, PJNF. It is already in 4NF, and every join dependency in the table is a consequence of candidate keys. Okay, in simpler terms, you should not be able to split a table into smaller tables. Okay, big table is there and small table we have split it. We can split it, but if you rejoin them to get more rows than you started with, then it should not happen like that. See, if this was a table, I broke into three parts and three parts are there, then when I did the join operation, it became a 4-row table. Okay, that should not happen. It removes the issues caused by join dependencies, especially when dealing with complex relationships. Why we need 5NF? Because the table, when you divide into many parts and we then join it, it is expected that it becomes an original table. If it does not become original table, it has some issues. Okay, we need to remove those issues. So let's take an example of a table not in 5NF. Okay, consultant projects and client locations. Okay, each consultant can work on multiple projects at multiple client locations. Got this point? Now consultant is who? Alice. Alice is working on project A and project B and working in locations New York and London. Now Alice is working on app A in London and New York and app B in New York. Okay, now when we break it into the three tables, what will happen? Alice is working on project A and B, and the consultant, which is Alice, is working in the locations New York and London, and the project location, which is there, app A is in New York and app A is in London as well, and app B is in New York. Now when we join these three tables, what will happen? We will get Alice joined with app B because app B is present and Alice is also present, and location is also present. So a new combination comes, which is Alice, app B and London. This does not exist in the original table. If you see carefully, Alice, app B and London. Alice is working on app B, but it is not in London. But due to the join operation, without FINF, what happened? This value got generated, and this is an unexisting value, which is spurious values. That should not happen. That's only we convert into FINF. How do we solve this? To convert into FINF, what we do? This table is already in FINF because any decomposition leads to data loss and incorrect rows unless we maintain all three attributes together. Okay, so in this case, the example, it is still already in the FINF, so we'll not make any changes, because if you make any changes, it will become wrong table. Now, to resolve this in any ways, if you want to do, you'll be adding another layer where what happens, you'll be checking if Alice and FB are working in the London or not. Okay, both combinations will be checked. A constraint will be added. It will be checked. If it is having that, it should be ignored. Okay, or there should be null value. It should not have at least London. Okay, that will give a wrong value, and null value is there means there is nothing working on that. Okay, means no one can work on a project without having any location. Okay, that does not make any sense. Okay, so FINF handles dependencies which arise in complex multiple relationships, and it ensures you don't get extra or wrong data. Okay. Now moving to the second half of the module, which is related to SQL. What is SQL? SQL is structured query language. It is a language defined for handling data in databases. SQL schema means it is a metadata. Metadata means you have the table values and the attributes. Now the attributes data types, what are the attributes data types? Those values will be stored in schema. So if we analyze schema from the top, you will be getting to know how many attributes are there and what are the attribute types of it. Okay. And what is a catalog? It is a named collection of schemas. Okay, and schema we can create directly by using the values here, and schema will be created. Okay, now after creating schema, we'll be creating a table means we'll be able to insert the data in it. So basically we'll be using this command create table and the table name, which is employee here, and which attributes we want we'll be putting here, and which values we want. Means the data types, right? Is it char, is it decimal, is it int, and is it boolean, or is it bits? Whatever it is, you have to specify it here. Okay, and you have to also specify if it is to be kept as not null. Okay, if it is kept as null means it can have in empty values, but some things cannot have empty values. Means for example, fname means it cannot be null. Okay, there's no person, like there is no name for that person. Okay, so everyone has a name, right? So fname cannot be empty like that. Okay, and we'll also specify primary key whichever we want. Here in the case SSN, and SSN also cannot be null. Okay, there is no student who does not have any roll number. Okay, like that. Now which data types are available? There are 4 data types: numeric, character string, bit, and boolean. Okay, date and time is also there, but it is not much used. The most important ones are numeric, character, string, and boolean. Okay, bit string. Now numeric data type like the integers, floating points, or the decimal values. In string we have the fixed and varying length. If you know how many characters are there, you can put it as fixed character, or if you use varchar means variable characters, so it will be having a number of characters where you can enter the maximum number, how much ever it is defined, and it is not defined, but how much space is there in the system, that much you can put. There is no restriction on that. Okay, that's what I'm trying to say. And bit string means if you want to store a string value, you can use this one. Fixed length and varying length is here as well, and the boolean value can store either true or false, and the date value can store in the form of YYYYMMDD. Okay, and you can store the time also in the form of hours, minutes, and seconds. Now there can be constraints in SQL. Okay, because you cannot insert whatever value you want. If you are inserting a value in a student database and you do not insert a roll number, that is a constraint. You have to insert a roll number, otherwise it is a fake student, because every student has a roll number. Okay, that is a compulsory thing. And a constraint is like a not null. Okay, like the students USN cannot be null, like that. Okay, can be specified on primary keys. Primary key is the most important key, due to which we identify the other keys. Okay, and default values can also be set for this attribute. If you want some default value in this table, like some default value will be storing it here, that will be also possible. Now an example is here: create table employee D number, which is department number. It is an int value and cannot be null, and default is 1, because there is no employee who is not working on any department. That is not a valid employee. Okay, so therefore we specified not null, and default also we can specify. If you have not specified what is the value of the department number, by default it should be 1 instead of null. Okay, that is what is the not null constraint. Okay, and another constraint you can put as unique, because two people cannot have the same roll number, right? So you can put a unique, so that everyone has a unique roll number. So for example, if you want to put unique on the department name, because two departments cannot have the same name obviously, so d name varchar and you put unique. Okay, and you can use the foreign keys because two tables will be requiring the department name, department table, and employee table. Employee is working on that particular department, and that particular department's more information is present in the department table. Okay, so an example is given here. You can have the foreign keys present here, and you can add the default values, and you can have the unique value which I showed at the top, right? And the foreign key means it will be having a reference between manager SSN and in the employee SSN, because manager is also an employee. Okay, so manager's data will be there in employee database as well as it will be there in the manager database. Okay, so there will be a foreign key present. Now, when an integrity is violated, SQL rejects the update operation and it is called restrict option. Okay, restrict. Constraint may be given by giving constraints for the naming the following word constraint. Okay, means whatever constraint you want to give, you'll be giving constraint name and you'll be defining it. Okay, like for example, check. You can give a check constraint. Check if department create date is less than manager start date. See, if a department is not there, can manager start working on that department? Obviously no. So first department gets created, then manager gets created. Suppose you have a row in which manager start date is first, then the department was created. It's a wrong row, right? So basically by using that you can understand if any false rows are there by using the constraints. Okay, and check can be used to specify constraints on tuples. Okay, next, basic retrieval queries. How do you write a query? Okay, suppose you want to retrieve the birth date and address of the employee whose name is John B. Smith. Okay, you want to know the birth date and address of the employee. Which employee? John B. Smith. Now what you will write? Select B date address from employee, where F name is John and middle initials is B and L name is Smith, because John B. Smith, right? So you'll be able to by this command get that birth date and address of John B. Smith. Okay, that is how you write this query. Next query, retrieve the name and address. Okay, name and address of all employees who work for the research department. Select the F name, L name, address from employee comma department, where department name is research and department number is department number. Okay, so whichever is the department is present here, that will be taken into consideration, and the department number will also be taken. So you'll be able to see all those persons name and address who work on that particular department. Next, for every project located in Stafford, list the project number first, second, control department number, third, department manager's last name, fourth, address, fifth, birth date. So all these things will be writing in the first line. Select P number, D number, and L name, address, and B date. From which all tables? We need project table, department table, and employee table, where department number is department number and manager SSN is SSN and project location is Stafford, which they are given here. So these tables they will be giving you in the exam, and they will be telling you to write the query based on seeing the table. Okay, here I'm just telling in air without referring any table. But you get the point, right? Whatever is the tables which is existing, like the project table, department, employee table, you'll be seeing those tables and we'll be writing these queries. Okay. Now what is alias? Alias is those values which are referred to in the different table with same attribute name. For example, the employee is also having a name as well as department is also having a name. So how do we differentiate? If we do select name, what it will print? Employee name or department name? It will not print anything because it is ambiguous. So that's why only we use alias. Okay, alias means what? I have to select employee name and department name, right? So what I will do is select E.F name, E.L name, S.F name, S.L name. What you will ask me, what is F? Supervisor table. Okay, and E means employee. So we are specifying it here from employee as E and employee as S. Okay, means supervisor is also an employee, obviously. So supervisor will also be considered as an employee. So wherever the employee's supervisor's SSN is equal to the supervisor's himself's SSN, that thing we have to select. Okay, like the query is for each employee retrieve the employee's first name, last name, and the first name, last name of his or her immediate supervisor. Okay, means you have to take the employee's name and the supervisor's name, whoever the supervisor is. So supervisor is also an employee. So basically what we do, employee super SSN, supervisor SSN is equal to the supervisor's SSN. Okay, so here we use the aliases E and S specifying the tables which you are referring here. Okay, that is called as the aliases or tuple variables. Now we can also retrieve all attributes in a particular table by using the star operation. Select star from employee where D number is 5. So all the employees, all the attributes will be selected wherever the department number was 5. If you don't want duplicate values, we can add the word distinct. Okay, if there is duplicate salaries, okay, means 5% salary is 10,000, another 5% salary is 15,000. So I'll select all salary from employee. It will select 10,000, 10,000, 10,000 5 times, then it will select 15,000 5 times. I don't want that. I just want to know what are the two different types of salaries present. So I'll write distinct salary. Select distinct salary from employee. What will happen? 10,000 will be printed, 15,000. That's all. Okay. 10k will be printed and 15k. But if I do in the first one, what it will print? 10k it will print 5 times, and then it will print 15k 5 times. Okay, that is a waste of time, because I don't want to read 10 values for two result, right? That's why write distinct if you want to avoid the duplicate values. Now you can use the string matching and arithmetic operations. For example, like retrieve all the employees whose address is in Houston, Texas. So select F name L name from employee where address is like Houston and Texas, because they can have something previous to it, like the door number and street number and the city and those things. After this they can have the country name and the zip code or something. In between it should be there somewhere. So we'll be writing percentage to include all those things which are previous to it and all those things which are after this one. Okay, if we just give Houston and Texas, no employee will be selected, because no one will put their address as Houston, Texas. You'll have to put the address till the door number, right? So those things will be there previously. So all those addresses will be selected which has these keywords, and before this and after this let whatever it be there. Okay, so this value replaces all the n number of values. Okay, there's no limit. But if you want just one digit here, for example, in some place it is 1 Houston, 2 Houston, 3 Houston, 4 Houston, I just want to know that places. So what I'll do, I'll put an underscore. It will just match a single character. If it is having multiple characters, it will not match. Only single character it is there, it will match. For example, find all employees who were born during the 1950s. So 1950s means I'll be writing here 1950s. 50s means 51, 52, 53, 54, like that. So here will be a dash here. This is a single dash. Okay. So here it should be 19. Okay. 9 and 5. Now here whoever is born in 51, 52, 53, 54, 55 till 59, all those will be selected. Okay. That is called as a like command. Okay. Like operator. Now another example is here. If you want to select all the employee salary, but you want to increment those salaries and view it as 1.1x, means 10% raise. So basically you'll be writing the same values here, and before salary you'll be writing 1.1 into, so that the in the final result you will be able to see the salary with the increased value, and in that column at the top it will not be salary, it will be as increased salary. Okay, so that will be present at the top. Okay, so that is what is called as the what is this called, this is the increment operator. Okay, you can change this values here and then you can print it. Okay, like that example is here of the between value. You want to select the employee whose salary is between 30k and 40k, so we'll be writing salary between 30,000 and 40,000. So it will select all the employees who is working in department number 5 with salary between 30,000 and 40,000. Now ordering of query results. What are the query results? You want to see it in ascending or descending order. Okay, what we do, select department name, employee name and the project name, and from the respective tables where d number is equal to this, order by d dot d name, e dot l name, e dot f name. What does this mean? Categorize it based on the department name. Next it will categorize based on the employee name. For example, if there is 4 departments a b c d, so a will be first, then b, then c, then d. So after that employee's l name will be taken into consideration, the employee's last name, all the persons in the department a, ascending order. Then if you want to specify it, it will be becoming descending order. Okay, just confirm it once. I'm not sure by default which it is, but in default it will be one of the orders. If you just write this command, it will be sorted in ascending or descending order, but you can specify whichever you want as ascending or descending. Okay, next, insert, delete and update commands. Okay, insert means if you want to insert a value, how you will insert into employee. Okay, insert into employee Marini, and the phone number is given and the birth date is given and 98 the address is given, and you will be specifying all those values. So all those values will be inserted on those particular attributes. Okay, means that column values. So here is the insertion command. To delete the command, you'll just write delete from employee where l name is Brown. So all the employees whose last name is Brown, they will be deleted. Like that only we can delete using specifying condition. If you don't specify condition, all the employees can be deleted. Update means update which table, update project, set p location. Okay, what we have to set, we have to set p location is equal to this and d number is equal to this, where p number is equal to 10. That means update this table and set wherever p location, set the p location as Ballard and d number as 5 wherever the project number is okay. For all the project number 10 inside this table, set the location as Bel Air and D number as 5. Okay, or you can set the salaries also like this. Update employee set salary is equal to salary into 1.1, where department number is 5. So basically, the department 5, all the employee got a salary of 10% hike. Okay. Now, additional features of SQL. This is the last topic. So, what are the additional features of SQL? You can specify the complex retrieval queries. Okay, you can have a combination of different types of queries, and you can have various techniques for writing the programming in various programming languages, and you can access the specific physical database and define the things which is to be done using a storage definition language. You can have transaction control commands, and it can be used for granting and revoking of privileges to users who can access what and do what, and it can also have the language constructs for creating triggers. And SQL has the powerful capabilities for handling the object oriented programming, which is object relational. And finally, it can interact with new technologies such as XML. Okay, that's all for this module. If you found this video helpful, please do like and subscribe. It helps me make more videos like this, and thank you so much for watching. I'll see you in the next.